Hey Mohammed. Today I'm going to explain my project is about AI image protection using convolution neural networks. So first let me explain what is this project is about. AI image protection is a technique where a computer can look at an image and automatically identify what is inside in it. For example, it can detect whether an image is contained a cat or dog or an aeroplane or a medical tumor. Uh, in real-time applications, these are used in many industries and many medical fields. This is done using a deep learning method called convolutional neural networks, or otherwise called a short form as CNN. So now let's understand the main idea of CNN is a simple way. A CNN works like the human eye and brain. It looks at an image and uh, is look at an image and it is always um, detects edge and lines. So uh, whether it first detects an edge and the lines, then it finds texture and patterns. There are lots of uh, structures that have been used. First is image classification and object recognition and deep learning powered. It is about a computer analyze an image and automatically identify what inside in it. Object recognition, it means it detects an object that has been well trained. For deep learning powered, we use a CNN technique that mimics the human visual system. So I have already said that like a human eye and right, it works like a step by step process. First input an image, in which it will fetch data, um, manual timing confirmation, and it will gives us error prone and error prone not scalable, edge detection, next texture and patterns, future maps, and classification. In which this is the steps by step whether the human eye it will works the convolution matrix. So let's just why manual image classification always face. It is about the three things the it is always fine. First of all, the time consuming, error play prone and not scalable. For example, it is in a medical field we are always known as a wrong prediction can be always very dangerous. So we need an automated system that is very fast and accurate, and it must be very reliable. So we use it as this as an problem statement, and we can easily solution and make a better decision making. For using the next CNN future extraction, for users we use a CNN VDD16 and NextNet 50. First of all, what is mean by I also already said that what is mean by CNN is a convolutional neural network. It is about for future extraction. For transfer learning using model like BG16 and NextNet 50. Transfer learning means we use model like that is already trained on a large data set and adapted it for a task, any task that we have assigned. This helps us achieve high accuracy in even less data. So next one is about CA for 10 bench dataset. It is about a dataset that have been used for. It contains 60,000 images, 10 categories like aeroplane, car, bird, cat, dog, and etc. Image is processed and researched before giving it to the original model. Now let me explain the workflow of this project. The system works in 6 steps. Load and process image. First it will load and will process the image. Next apply data augmentation like rotation and flipping. And third one is about build the CNN model. And fourth one is about train the model. Fifth one is about evaluate performance, deploy, and the last one about deploy using a web application. Finally, the user can upload an image and the system will predict the label and confidence score. Now the result will always perfect, and there is no there is no difference occurs. Now let's talk about the result. The model achieve around 93% accuracy and it performs well for most categories. Some confusions happens between similar objects like cat and dog. This shows the model is highly effective and reliable. As the real world applications, it is also used in medical imagination for disease detection, e-commerce, and agriculture, driving cars, and some of the agriculture for crop monitoring. And the sixth step end-to-end pipeline or load and pre. Firstly I said that the process that have been done, it will load and pre-process data augmentation, and it will build a CNN model, and we will train the data and evaluate the data and deploy to the web app. So these are the accuracy that I have told 93%. Oh, these are the future and real world application that have been used in for. um, Finally, these are the next steps to implementation, and the project summary. Successfully implemented CNN and transfer learning, and it is next steps future in object detection. It is used for object detection and image segmentation and advanced AI models. I like to conclude by saying that this project successfully demonstrate how CNN and transform learning can be used to build a powerful image calculation system. So thank you, students.